Hello, and welcome to the HBCU STEM Undergraduate Success Center. This video is a brief review of the paper, Development and Validation of Scientific Literacy Skill for College Preparedness in STEM, with freshmen from diverse institutions. The term scientific literacy was first coined in 1958 and was used as a way to revamp America's science education. Although a major goal of STEM education is to develop scientific literacy, prior efforts at measuring scientific literacy have not attempted to link scientific literacy with success in STEM fields. Although there are challenges in defining scientific literacy, it is nonetheless an important variable due to its impact in science education and teaching. The scientific literacy skill for college preparedness in science, technology, engineering, and mathematics was created to predict the academic preparedness of incoming freshman STEM majors. The scale is unique in that it assesses STEM students through a utilitarian scientific literacy lens. This paper presents the theoretical framework for the development of the scale along with supporting data on its validity and reliability. The purpose of the current study was to take the scientific literacy scale and develop it within the context of a utilitarian scientific literacy, which allows for the independent assessment of three dimensions of scientific literacy. The three dimensions include attitudinal and behavioral domains of scientific literacy, content knowledge of scientific concepts, and scientific reasoning skills. However, in addition to establishing a theoretical framework, the authors also investigated the instrument's reliability, stability over time, and content validity. The sample consisted of 1,349 undergraduate STEM students in their first semester of college. Participants' ages range from 16 to 21 and included freshman STEM majors from various ethnic backgrounds. Participants were recruited from 7 institutions, all of which were 4-year colleges or universities. Regarding the instrument reliability, the researchers found that the scale reflected favorable reliability for almost every dimension. The attitudinal and behavioral domains of scientific literacy had a high alpha at 0.86. In regards to content knowledge of scientific concepts, the authors note that performance scores in individual content areas are knowledge-dependent and therefore not strictly psychometric subscales. However, the content knowledge dimension had satisfactory internal consistency with an alpha of 0.73. The scientific reasoning dimension also had a favorable Cronbach's alpha at 0.72. Overall, scientific knowledge was defined as a combination of content knowledge and scientific reasoning and had a favorable alpha at 0.80. In addition, the authors examined the instrument stability over time. The test-retest method was employed to additionally quantify reliability by examining scale and subscale stability over time. A total of 91 students participated in the test of the instrument stability over time. A 7-day latency period was implemented between session 1 and 2 to avoid carryover effects. The authors found that all 5 attitudinal behavioral domains of scientific literacy subscales were positively correlated with each other from session 1 to session 2. The attitudinal scale showed the strongest correlation at 0.88, which translates to sufficient stability for the dimension. Content knowledge in its individual discipline areas had significantly positive, moderate to strong correlations between test sessions. Scientific reasoning items as a whole had a very strong test-retest correlation at 0.80. In addition, the authors investigated the scale's content validity. The authors examined the content validity of content knowledge sections of the scale to ensure that the sections were appropriate measures of scientific knowledge. This study included 85 faculty members who had expertise and undergraduate teaching experience in the biological, chemical, and physical/engineering sciences. Faculty were asked to answer 4 questions for each of the 26 items on the scale. The 4 questions included: if this true or false statement is answered correctly by someone, it would demonstrate their content knowledge of B. This true or false statement is written clearly and precisely and is scientifically coherent. Before beginning any college work, a first-time freshman STEM undergraduate should be able to correctly answer this true or false statement. And a freshman STEM undergraduate who has completed a college-level introductory STEM course should be able to answer this true or false statement correctly. The inclusion criteria for a survey item was set at a threshold of more than 50% of respondents selecting agree or strongly agree to the question on the 4-point Likert scale on all 4 assessment questions for that item. Due to results from the faculty survey, 2 content knowledge statements were eliminated, resulting in a total of 24 items. In conclusion, the authors state that the scientific literacy scale can be regarded as a consistent measurement device, exemplified by its high test-retest correlations. In terms of content validity, researchers determine which items to include by noting which items to which the majority of faculty answered agree or strongly agree. The final version of the scientific literacy scale had 24 content knowledge questions and 8 scientific reasoning questions.